Okay, good morning everyone. Thank you very much for inviting me to this conference. Okay, I'm Roberto Tonelli. I'm professor at the University of Cagliari. I'm also an INATMA member together with Wim Salman and Katrina, and we are together in the same group of education working group at INATMA. That's why I'm here. I'm just here to talk about what are the problems related to educational skills in blockchain technology. I'm here just to bring to your attention my experience in the field, and I'm going to start with my presentation. It's this one. Okay, so what are the problems, the main problems in blockchain education? Of course, as any new field, there are many different problems. First of all, there are many different facets. It means that the technology has these different aspects, like the economical side. You know about cryptocurrencies, so you need like to understand the phenomena. Expertise in economics, how trades are made between cryptocurrencies, how to exchange them, how to give a value to a cryptocurrency, and so on. But also you have the technology itself, like the real blockchain technology, means the informatic point of view. And you have also aspects related to legal aspects, like what is the real value, what are you allowed to do with assets? Can you exchange assets using this technology, and what are the legal aspects about that? And one of the other problems is that we have missing standards in academic education, which means that, for example, in older subjects like mathematics, engineering, you already have standardized everything, so that the topics dealt with in Italy, in engineering, in Germany, in France are the same. So you have a standard preparation for all your students. And this is not true for blockchain technology because, we still don't have standard in academic education. And another aspect is the slow time to market for academic institution. What I mean is that if you want to propose to your university a new course, you have to wait. You have to pass through a long project. You have to propose. Okay, you have a long procedure, and you can wait years. Okay, here we are again. And this means that the technology goes faster than the academic. So basically, you lose the right moment to get into the market. And another problem is that it's plenty of non-conventional material, means that you can find information on the web, of course, many YouTubers, many social media, blogs, and so on. But are they reliable? The problem is that with modern internet technology and the modern web, everyone likes to explain things to others, to expose himself, herself to others. And this is sometimes risky because it's plenty of wrong, I would say, material, inaccurate material, and so on. So, how to proceed, basically? The answer from the point of view of academic institution can be personal initiatives. With this, I mean that if you are held in a course, for example, I'm from the computer science and mathematics department, so if you are held in a course in the informatics, in a master degree, then you can try to insert some topics about blockchain technology into your advanced course. So this has been done at our university from a colleague of mine. But again, it's a personal initiative. It's not completely supported by the academics. And the other answer can be the schools. And I'm here to talk about the schools we organized in our city, in our university, in these years. Schools on blockchain means that we propose a program which hopefully covers all the main topics related to this technology and teach to people how to take all this technology. We started at the University of Cagliari with the first blockchain school in 2018, and actually we started working on the blockchain technology in 2015. But after 2-3 years, we proposed a blockchain school that has been held in 2018. And last July, we had the third edition, which is the third because we had to stop for 2 years because of COVID problems. So we had 18, 19, nothing, 22. And what is the target of this school? Okay, in general, are master and PhD students with preferred skill in computer science, but it's not reserved only to those guys. We also accepted professional researchers of other fields and professors, and also people with no programming skills. So the target was quite general. The plan. Okay, so what are the topics we dealt with in our school? Okay, general introduction to the problems and to the technology. Of course, we also choose to give an idea about practical applications because maybe it's one of the most interesting things regarding this technology. And of course, we had to talk about the two main, the most used technologies, which are, of course, Bitcoin and Ethereum, as probably every one of you knows. And we also had a part a little bit more technical about the use of smart contracts and the use of Web3 potentialities, which means that we had laboratory sessions for developers, teaching them how to write smart contracts. And the laboratory session was devoted to the Ethereum technology and to the Solidity programming language. And also they were devoted to develop the apps, means distributed applications, so that we provided a whole package, so from the beginning to the end, so that at least in principle, attendees were able at the end to deploy the app on the web. And well, we also dealt with more advanced topics because we hosted two guys that were my students that nowadays they are working at the Ethereum Foundations and they are working on topics about zero knowledge proof. So we also deliver those kind of topics, but I'm not going to talk about it today. So this is okay, the program we had 2 months ago, basically. So you can see here, of course, a first introduction, upper left, to Economy and Law by Professor Filippo Zatti. We had the speakers mainly from the academia, but we had also speakers from the industry, like Angelo De Caro is on IBM Zurich. And these two guys are from the Ethereum Foundations, and also some other people coming, speaker coming from the industry. And I'd like also to show you this on the bottom left, Emiliano Verlini, which is an employee of Poste Italiane, because one of the ideas I had in mind is that Public blockchain are well known, private blockchain are spread, but what about institutional blockchain? Okay, people usually don't know about that, but I mean, there are initiatives brought forward from the public institution. In Italy, we have this initiative, which is the Italian Blockchain Service Infrastructure, which is a twin of the European Blockchain Service Infrastructure. I don't know about if you know about the European Service Infrastructure project. It's a European project which collects altogether 27 countries in Europe, and they share a project about providing nodes for institutional blockchain, so that they can use the blockchain to provide services to enterprises and to citizens in Europe across border. So it's kind of an institutional blockchain, which means that supposedly it should be there forever, because if you use a private blockchain or public blockchain, you cannot be sure that it's going to be there in 2 or 3 years. Of course, Bitcoin and Ethereum are quite stable, but many blockchain projects are born and then failed and they disappear. So I had also the idea of introducing to our students the Italian Blockchain Service Infrastructure, which is a public infrastructure providing blockchain services made by different universities in Italy and public institutions like Poste or INPS, which is the National Institute for providing the money after you retire. I don't know. Okay, and other big institutions in Italy. So I'm just going through some few slides of our speakers. For example, Filippo Zatti, which is a professor at the University of Florence, presented his topics on the economy and law of cryptocurrencies. So, first of all, what are cryptocurrencies and what are they regulated? And he introduced also, of course, general concept. But he also had a talk about MiCA, which is Market in Crypto Asset Regulation Proposal, which is a proposal from the European Union, with the purpose of set some regulation on crypto assets. Of course, it's an ambitious project. I can set your attention on something which, in my opinion, is kind of strange. Like if you see here, they refer in this project to crypto asset used as a means of exchange that purpose to maintain a stable value. Okay, so everyone knows that cryptocurrencies are not stable at all. Okay, but in their tentative to regulate, they are talking about stable values. So this is just to let you understand how difficult is the topics regarding to the normative, the regulation of the cryptocurrencies. And of course, it's referred with respect to the fiat currency. Or rights here, okay? Assets that represent rights which may be transferred or stored. For example, usually when the parents die, the children have rights on their assets, so they inherit. But for crypto asset, this is basically impossible if it's not done explicitly, because the crypto asset is held by the person or the institution who has the keys. So if the parents don't give the key to the children would get nothing. Okay, and this is a problem defining the value of crypto assets in general and how they can be transferred and stored. I need to rush. Okay. So what else has been presented in our school? Of course, a technical introduction to blockchain. So what's, first of all, the definition of a decentralized ledger, and with the different phases, like differences between permissioned and permissionless blockchain, and of course the problem of consensus, which means that having different nodes with exchange information across all the world and with no synchronization, basically, and with transaction arriving at any time. And the way to work with this problem is that basically you need a consensus mechanism so that all the nodes, when they update the states of the blockchain, they must all agree to the new state. And this is obtained in different ways, but the main one is the proof of work, which means that all the nodes, okay, I'm gonna go back there. Basically, all the nodes try to solve a puzzle, which means that they need computational power, basically to put together all transactions that they consider good, because every node can choose different transactions. They pack all together, they make some heavy computation, and they obtain what is called the hash of the proposed packages of transaction. And if the hash respects some condition, I mean, the guy wins and obtain also some reward, and propose this block to all others. This is one of the ways to solve the problem of consensus. Other main technologies are, of course, digital signature, which means that this is done basically using asymmetric encryption, which means that you have a public key, and only you have the private key related to the public key, and you can prove using your private key that you are the owner of the public key. In some sense, you can prove your identity. And it's easy to verify from, by another person, another entity on the web, that only you had the possibility to encrypt or decrypt, that kind of stuff. So that's kind of a digital signature. What else? I believe I have just a few minutes left. So we also dealt with software engineering principles, means that we believe that this is very important, so that people, technical people, developers writing code for blockchain applications, they are not aware of the way software has to be written. And you can find many young developers, just they go there, they write code, and the code is a mess, and start having bugs after 2 weeks. But the problem is that once you deploy something on the blockchain, you cannot get it back. It's deployed, you cannot change, you cannot fix bugs. So if your code is wrong or full of bugs, you cannot do anything. You have just to throw it away and redo the work. So software engineering teaches our developers how to build hopefully bug-free, it's impossible, but at least a nice software product. Finally, we adapted, of course, traditional software engineering to specific blockchain technology. Finally, we have presented Ethereum Smart Contract Development Lab, where we taught the people how to use MetaMask. I don't know if you're accustomed with that, which is a public wallet that allows you to manage transactions and also to deploy smart contract on the Ethereum blockchain or on testnets. We use testnets because the Ethereum blockchain, of course, you can use it if you have Ether, but Ether, of course, you have to buy them and any transaction costs. But you have the alternative to use testnets, which are basically twin of the main blockchain, so you can do whatever trial you want, because the Ethers are provided for free. So you just need to use MetaMask. You ask someone to give you fake headers. They will give you fake headers, and you can use that to make your trials on the testnet. Finally, we talked about some tools to develop and to deploy smart contracts together with MetaMask on the testnets. And at the end, of course, you need to know how to program smart contracts, so you need to know the programming language for writing smart contract on the Ethereum blockchain. And finally, we had a laboratory session to build directly the apps on the web. So to present the web pages, and we use it to produce non-fungible tokens of artworks to expose them into a web page produced by our students at the end of the course, like this one. So a web page where you can press buttons to edit, to buy the artworks with all the references to the blockchain and to the uniform resource identifier on the web. So these are the main ingredients we thought that are needed for a technical person working on blockchain in these days. And that's it. Thank you.